Hello, everyone. My name is Kammerlocher. So today I will be the host for the Dev Open Office Hour and also the presenter. So bear with me if I miss anything. But today we want to go and cover CIP-113 and especially the KYC part from that. For everyone who don't know me, my name is Kammerlocher. I'm a senior full stack developer at the Cardano Foundation. I'm working here for now nearly 2.5 years and working on different topics. And one of them is CIP-113 and helping Giovanni to bring identity into these programmable tokens. And today we want to dive deeper into how we are going from CIP-113, so from the not yet standard, to an actual implementation. But I want to ensure that everyone is on board and everyone is on the same page. So that's why I have 2 slides with some basic knowledge to bring everyone on the same base. And the first one is, what is CIP-113? I know that we already talked about it a lot, so mostly it was done by Giovanni. And if you want to dive deeper into the topics, then I can highly recommend the recording from the Open Office Hour, where Giovanni did all of the deep dive into CIP-113. So just watch this recording and then you get everything what you need to know. So I will just cover the basics and just a rough framework. So CIP-113 is already around for quite some time. So if we look at the pull request, for example, so that's why I said CIP-113 is not yet a standard. So it's a CIP candidate, and this pull request is already around for quite some time. So it was started more than 3 years ago, so in January 2023. So there was a lot of discussion going on back and forth, multiple iterations and so on. And now we have a quite stable implementation. We are also currently in the second iteration in the auditing of the implementation contracts. But what is CIP-113? So as you all know, we in Cardano, we have Cardano native tokens, which are permissionless, which are first-class citizens on Cardano. And that's very good. But if we want to go into the direction of compliant stablecoin and tokenized assets, then we need to be compliant. And to do so, we need to apply some rules and laws, which is not possible with these permissionless tokens. That's why they came up with an idea to add programmability on top of these tokens. And that's what CIP-113 is about, so about programmable tokens. But how do we achieve this? So in CIP-113, we have a registry. And this registry is implementing the general rules about how everything is tied together, and it also has a registry. And the substandards are then implementing basically the rules which we need for specific use cases. To do so, you are adding a registry node, and in this registry node, it is referencing different smart contracts for the different actions. So, for example, for mint and burn, for transfer, and for third-party actions like seizing and freezing, these contracts are then always involved in the transactions through the withdraw zero trick to ensure that this logic is always taken into account, and that's roughly how it works. But I don't want to talk about CIP-113 in general today. I want to talk about a specific substandard. And the substandard I want to focus on today is, as I said, is based on identity. So how are we bringing Know Your Customer to these programmable tokens? But first of all, I keep it quite short as well. So why does KYC exist in the first place? Note here, I'm not a lawyer and I'm not a banker, so I'm a developer. So that's why I try to explain it quite roughly. KYC is needed because, as I said, regulated assets need to apply different rules and different laws under the different jurisdictions they are issued in. So, and native tokens are bearer instruments, as I said. Whoever holds it can do whatever they want with it, and that doesn't fit with the regulated finance because it can't legally work. Because as I said, the tokenized assets are always having these laws which they obliged in. For example, if you're minting gold, then there's still some rules you need to apply for this specific gold. It doesn't matter if it's just put on chain, so you still need to apply these laws. And one of the pillars for these laws is identity. And as I said, these permissionless tokens don't have the identity. That's why we are working on that. And if we are adding KYC to this token, this will unlock a few different use cases and different kind of tokens. So for example, reward assets and tokenized securities. And if we get this onto Cardano, then we will get more institutional capital, which is also good for us. But since we are in the developer open office hour, I want to directly dive into how are we building this. So I also have live demos, but first I want to explain how it works. So how we are basically getting this traditional finance compliance into our programmable tokens. And we came up with a quite simple solution. So the first one is if a token issuer mints a token, then he's minting also a global state. And this global state can hold some kind of different information, which is configuring the token. Basically, this global state is minted with a one-shot minting policy, so that you only have one. And then this global state for KYC, we need a list of trusted entities. Because in some cases, the token issuer doesn't want to do the KYC all by himself. So that's why this list is basically a delegation of the KYC process. And you're adding trusted entities in there. So basically, they're public keys of these trusted entities who are responsible for the KYC process. So in case Alice wants to send Bob some of these programmable tokens, then you need to add the reference input to the transaction so that the involved smart contracts can read the trusted entity list and know who's allowed to do the KYC process. Then comes the step of the KYC. So in this case, we try to keep it as flexible as possible. So that's why the on-chain part is quite slim, and that gives us a good advantage because we can replace this KYC process whatever it needs. So we can put in here, for example, the traditional banking process or whatever we need. So once Alice is doing the KYC process, then the trusted entity checks everything, and if it is good, then it is generating a proof of KYC. So it's basically a payload which contains the user public key hash, a role, and a valid until, so that the signature is invalid at a certain point in time. And next to this payload, the trusted entity is also signing this payload. And this goes into the redeemer, and then the transaction can check if the payload matches to one of the trusted entities in this list. And and then if it matches, then it's accepting the transaction, and the transaction goes through. And as I said, so for example, in classical finance, you could put, for example, the classical finance KYC process in there. So I'm quite sure that everyone already did at least once this process. If you apply for a PayPal account or Revolut or a bank account, then you need to apply, submit your docs, then you wait. It depends on the institute how long this takes. They confirm your identity through all of the documents you're giving them. They're screening your names against sanction, rating how risky you are, and if everything's good, then they are approving and you're cleared to go. This can take some time, which is annoying. So that's why today we are using a different reference implementation because we are in crypto. So that's why we are using cryptographic solutions as well, also for our identity. And we already have a really good solution in place, which is Viridian, which is based on verifiable credentials. So this KYC process would change slightly. So Alice would then present their verifiable credentials from their Viridian app to the trusted entity, and the trusted entity can then check the complete root of trust and the complete credential chain of your credential and see directly if it's valid or not. Out of scope for today is how to get a credential. So for now, we assume the user has a verifiable credential based on a trusted root of trust. And but let's go into a live demo because I think that's more interesting, just to see how then looking at slides. Because we have a programmable tokens platform which is currently running on preview, so that anyone can try it out and play around with it. So big credits here to Giovanni as well, because he built most of this stuff. And yeah, so if you want to give it a try, then you can go here as well and see how it works. I'm pasting this link in the chat, so I know that it's probably not in the recording, but nevertheless, what you need to do, what you can do here is you can register tokens. So we already have here a few substandards implemented that you can use to play around with it. And the one substandard I just roughly sketched is the KYC token. This is for the sender verification. In the minting process, you have different steps. So the first one is that you can also use CIP-113, which is the carry-based credential CIP, which you can use to prove that a specific legal entity did with their mint the specific token, and they can prove it with their VDI, for example. But we'll skip this for now because I think there's also an open office hour about CIP-113 if you're interested in going deeper into that. But in this platform, you can just provide some information, say that you want to have a different name, who gets this token. You can also add CIP68 metadata, so that's quite good that you can combine these two CIPs to get even more functionality. And the first step here is that you're configuring then the global state. So in the global state for this substandard, we have a mintable amount, we have security informations, and we can populate the trusted entity list. For now, I'm just using the signing key, which is in the backend, because that's simpler. But I can also load my own public key and add myself to the list. When we are doing this, then we first need to mint the global state. It can take some seconds, so that's why while we wait for the global state to hit the chain, just a short excursus about our solution finding. So the current solution seems, I was a little bit worried at the beginning that it seems too easy, but we had a history of different solution we discussed in different rounds. And we went from having two linked lists, then having just one linked list, and they are differently connected, then dropping another linked list. So I think the current solution is quite lean. And the good thing is that since the on-chain part is quite slim, this solution is very flexible. And we got the feedback from our legal team that the flexibility in international finance is very important. So as much as we can slim down the on-chain part, the more flexibility will come in the off-chain part, because we can't fulfill every jurisdiction in the on-chain part. So that's why this solution is, I think it's quite good, so that they can do their business, what they are already used to do, and they can just integrate the solution quite easily. Okay, so it's still waiting here. But I prepared everything, so I already minted a token so that we can continue on that. So after the global state, there would be just one last step where you can mint the actual token, but I already prepared it. So here we have a token, which is called sender verification, which is exactly the substandard I just sketched. When you want to send something here, then you will directly see the KYC verification is needed for sending something. And if you do it, then the carry Viridian flow starts. So first of all, you need to introduce the backend the backend carrier of this platform with your Viridian wallet. This is done by exchanging the out-of-band introduction. So here I already have a Viridian wallet running in my browser that you can follow with me. What needs to be done is, as I said, so first both of them need to get to know each other. So my wallet already knows the backend, but now we need to share my information to the backend so that the backend also knows my wallet. This can be done by scanning the QR code, which is quite handy if you're using your phone, or just copy pasting it if you're in a dev environment. And once both resolve each other, the next step is that you need to present a credential. So as I said, we have different roles in there. So I'm just a user. So that's why I say, hey, I want to have the user rights, and tell the backend, hey, I want to present you a credential. Then I get a notification in my wallet. So this will happen on your phone, as I said, which says, hey, show me your credential. And I'm doing it right now. So then my wallet presents now the backend my Viridian credential. And if it's good, then we see the backend says, yeah, the credential is good. I checked the whole credential chain, the root of trust is okay, and so on. And then it's verified. And then I can start to send these tokens. So this is for, and then I can send it. So this payload will be added, as I said. So we can also look into the contracts, how it looks like. So everything is open source and the CIP-113 Programmable Tokens platform. We also have documentations about these substandards, how they are. And we can also have a look in here, how the contract is implemented. Because I think that's also quite handy, because having simple substandard implementations will help others to understand how to build their own substandards based on CIP-113. What we have in here is, as I showed in my first slide, is we have one validator for issue, one validator for transfer, and my substandard currently doesn't support third-party actions, but if you would have this as well, then you would have a third validator in here as well. And what happens in this validator is that we are first checking if this is called in the transaction as a rewarding script. So checking for the withdraw zeros trick, checking the required witnesses, checking if it's still in the validity range. And then we are doing the sender check by doing the validate KYC proof. And in here, we are basically extracting the signature and checking then the signature against the trusted entities in the global state, and checking then also the public key hash. So if the person is really the person in the payload, and if everything's fine, then it goes through, and then you can start sending them. That's for the sender verification. But if you start to think about it, then sender verification is probably not enough. Because what happens if I send tokens to someone who can't do KYC or is in a sanctioned country or whatever? So then this ADA would be locked. Or for example, if I intend to send some money to Mikhail, for example, then it would be quite unhandy if I tell him, hey Mikhail, I want to send you money. Could you approve it in your Viridian wallet? So that would be quite unhandy to involve him actively in the transaction. So that's why we extended it slightly to have also these receiver verification. And we did it by having next to the trusted entity list also a Merkle tree. So, and the trusted entity is then every time when you're doing KYC with them, then they are adding you to the Merkle tree. And in the redeemer, you can either provide your signed payload, or you can add a proof that you're in this Merkle tree, and you need to do this for Alice and for Bob. So this way we can ensure that both are KYC'd and these tokens and the receiver can really do something with these tokens, and they are not locked and lost. Yeah, that's for the receiver verification. As I said, this is also in the open source repository. If you want to have a look here, how does it look from the smart contract side? We are accepting basically a sender proof, which is either an attestation with the proof I just showed, or a membership proof. And this membership proof is then basically just checking if you are in this Merkle tree or not, and then the senders and the receiver is okay, and because that's done for both. In the programmable tokens platform, this would, for example, look like this. So I'm seeing directly that my KYC verification is good because I'm in the allow list. And now if I want to send something to someone who's not in the allow list, then I will directly see it that the user doesn't have KYC yet. So that's why they need to verify first before they can receive something. So that's why we ensure that it will work quite good. So now I was talking quite a lot about just these demo substandards. So because they are quite simple, but if we are looking at real finance environment, then the laws and the rules will get quite complicated quite quickly, and we need to apply even more rules. So that's why there's currently a substandard implementation, which is led by Fluid Tokens. So credit to them because they built nearly everything. We just contributed here the KYC part, so that this is following the same approach which we are suggesting. And this substandard, for example, is fulfilling the rules from the German and from the Swiss banking standards, which is quite good. And as I said, the rules are more extensive here because within this substandard, we not only have a trusted entity list. There's a registrar style model, role model implemented. We have an owner and we have power users with scoped powers. So a power user could have, for example, the right to blacklist or to pause, and another power user can, for example, mint and burn and seize, so that you can configure these. And also, as I said, we have in the transfer gate, we have that the sender is verified and not blacklisted, because we also there's also a blacklist in there, and same for receiver. And you can globally pause the transaction of these tokens under that substandard. And there's also, for example, a cap, which is ensured through the global state. And there's also all of the stuff which we need for ensuring that it's secure. For example, key rotations for the admins and so on. But yeah, if you want to go deeper into that one, then I can highly recommend this smart contract, because you see the functionality will be quite clear when looking only at the global state, because that shows you how much functionality is in there for, as I said, transfers, so pausing transfers, mintable amounts, power users deny list, and also configuring if you really need KYC. So you can turn it off for sender and only activate it for receiver, or turn off both. So that's also possible within the smart contract.
Hello. So
Hello.
I have a couple of questions. Probably one is kind of obvious, I guess, but maybe it's good to validate that. The global state that is minted at the beginning, it's something that obviously can be changed, right? So that
Yes.
they share list is not something that can be updated or like revoke some entity from doing that.
Yes, yeah, that's possible. So there's so you can that's a one-shot minting. So you can only have one, but you can spend it if you create a new one. So basically, updating it's possible as well. Yes.
Okay, and the second thing is so the whole process is that, for example, an entity doing KYC, like a company doing that, needs to this trusted entity needs to implement something that connects the things together. It is kind of a hard requirement. so that basically they release a specific credential, no, for example, that kind of attests that I have that I'm verified, no, in some sort of KYC. Is that correct? Yeah.
Yeah, so basically, the idea of having this on-chain construct is that these trusted entities are quite flexible. So they can do it with Viridian if they want to go this way, or they can use their already existing KYC process. And then the only thing they need to implement is basically updating this Merkle tree and generating the signature. So that's why I try to stress it that this approach is, we need maximum flexibility, and most of these trusted entities, they already have all of this KYC process in place because that's basically their daily business, and we just need to have a small piece to plug in to make it as simple as possible for them.
I think wallets, explorers, DEXs, they have to do something, right, to show the value of these balances. So from my understanding, it lies, it has to lie in a script address. So what's the effort of the wallet providers to implement that?
Yeah. So basically these tokens, so for example, in Eternal Wallet, you will see that you have three UTXOs in a specific address, which is not yours. So it's a different payment key, which is from the contract, but it's your staking key. So that's how it's tied together with this Franken address. And then that's basically what the wallet providers need to implement. So Eternal is already tracking it, kind of. So I think they just need to do one more step to show these tokens then also in my assets.
So you're saying it's a rather easy thing to do, or?
Yeah, CIP-113 is still quite complex from my point of view. But I just saw this today that already Eternal is showing this. I think they already made a lot.
I think most of them are showing this because of the Franken address. So because of it's a Franken address, and your reward credential is kind of part. So you have the payment credential coming from the script, but the reward credential coming from your own address, and that's why it shows up in your wallet. So most of the wallets already support this visually, but not the spending case. And the spending case is difficult, actually.
Yeah. But that will be on our roadmap as well, to improve the tooling around CIP-113 to make it easier to build actually these transactions and the spending. And yeah, as Fabian said, probably it will be quite complicated because they don't know the underlying substandard. So that's why it's something we need to solve.
So on the substandard, we can think of just a pluggable rule set, right? And when you explained that before, I was wondering what stops us from fragmenting into 1 million or 1,000 KYC substandards then that, for example, DEX, if they see that, or sexes or whatever, say, like this is too complex. I mean, we cannot integrate all of them. I think that's more for DEXs, because sexes have their own KYC standards.
Yeah, that's true. So that's why we want to push one reference implementation of a KYC standard before CIP-113 already launched, so that we have something which we can tell everyone, like, hey, this is already a functional substandard which is compliant to German and Swiss regulations and has KYC in there and so on. So that there's already something for the start of 113.
And I think you also answered it already in your question, right? So if there's a pain when you create your own standard that you're not listed, or if you do your own thing and you're not listed, and you need to care about becoming part of sexes, DEXs, and so on, also wallets, because effectively they need to know how to build a transaction to spend your token, then it incentivizes people to just go with the standard. And yeah.